Hello everyone, welcome to lecture on phase change on reflection or Stokes principle of reversibility. I am M. Satyavani, lecturer in physics, TNR College, Bhimavaram. In this lecture, I will discuss about the Stokes principle of reversibility. According to Stokes, when a light wave is reflected at a surface of optically denser medium, it suffers a phase change of pi or path difference of lambda by 2. This is known as Stokes principle of reversibility. For example, when a light ray is incident on certain surfaces, reflection takes place. Different mediums have different optical densities. For example, if the reflection takes place from rarer medium to denser medium, then the extra path difference of lambda by 2 is obtained. But there is no phase change when the reflection takes place at the rarer medium. Then proof for this Stokes principle. First of all, consider two mediums 1 and 2. Mediums 1 and 2. Consider a ray of light AO of amplitude A, which is incidenting on the boundary. These are the two medium. For example, this is air and this is glass. The second medium is denser than the first medium. Consider two medium 1 and 2. Medium 2 is optically denser than medium 1. The AO is the incident ray. That means this ray is coming from rarer medium to denser medium. At the point of incidence, a part of it is reflected and a part of it is transmitted into the second medium. Then the reflection coefficient is of the first medium is R and the reflection coefficient of second medium is R dash. Similarly, the transmission coefficient when ray enters from first medium to second medium is T. When the ray enters from second medium to first medium, it is T dash. Once again, I repeat this point. AO is the incident ray. Small a is the amplitude of the ray. At the boundary, a part of it is reflected. The amplitude of the wave is AR, where R is the reflection coefficient, and a part of it is transmitted along OC. The amplitude of the refracted ray is, or transmitted ray is AT, where T is the transmission coefficient from ray enters from medium 1 to 2. R and T are reflection coefficient of the first medium, and T is the transmission coefficient when ray enters from first medium to second medium. That is about the first figure. Next, now suppose that the directions of reflected and transmitted waves are reversed as shown in the figure. But this is the reflected ray. OB is the reflected in the first figure. If it reverses its direction, then it is along BO. In the first figure, the ray is along OB. In the second figure, it reverses its direction. Therefore, the direction is along BO. Again, it undergoes reflection. The amplitude of this ray is BO is AR. The reflection coefficient for this medium is R. Therefore, the part of the amplitude reflected in this direction is AR into R, that is equal to AR square, and a part of it is transmitted. AR is the amplitude of the ray, the transmission coefficient is T, therefore the amplitude of the transmitted ray is AR into T. That is about the first reflected ray. And the second ray is transmitted ray. If the second ray is reverses its direction, in this first figure, the transmitted ray is OC, if it reverses its direction, it moves from C to O. C to O. The CO is the reverse transmitted ray. We know that its amplitude is AT. A part of it is reflected and a part of it is transmitted into the first medium. The reflection coefficient for the second medium is R dash. Therefore, the part of the ray reflected into the second medium is AT R dash, and the transmitted part is AT into T dash. AT into T dash, where R and R dash are reflection coefficients. R dash is the reflection coefficient and T dash is the reflection coefficient when ray is traveling from denser to rarer medium, that is second medium to first medium. Here we have taken two media, 1 and 2. 2 is denser than 1. Therefore, R dash and T dash are reflection coefficient and transmission coefficients when ray traveling from 2 to medium 1. As there is no wave along OD, but in the first figure there is no, this is the incident ray, these two are the reflected and transmitted rays. There is no along this direction, OD direction. Therefore, the amplitude is equal to 0. There is no ray. But according to our discussion, the total amplitude of this ray OD, ART is from this reflected ray and AT-R dash is from this transmitted ray. Therefore, total amplitude is of OD is ART plus AT-R dash. ART plus AT-R dash. AT can, but there is no ray. Therefore, amplitude is 0. Therefore, AT is common. Then R plus R dash is equal to 0. R is equal to minus R dash. Along OA, AR square plus AT T dash. Along OA, according to this figure, the amplitude is AR square plus AT T dash. But according to the first figure, the amplitude of OA is only A. Therefore, AR square plus AT T dash is equal to A. Simplifying this equation, we get T dash is equal to 1 minus R square. From these two equations, if you observe the first equation, the two reflection coefficients are equal, and this negative sign indicates that a phase change, negative means cos phi. If you write this equation, minus as R is equal to R dash into cos phi. Cos phi is equal to minus 1. Here cos 0, here cos phi. That means there is a phase change of phi occurs on reflection from a surface backed by a denser medium. Once again, I repeat this point. In this equation, negative sign in place of minus, we can write cos phi. That means in between R and R dash, there is a phase change of pi 180 degrees, or phase difference of pi corresponds to a path difference of lambda by 2. 2 pi means a wave. From phase difference between first and last points of the wave is 2 pi. 2 pi means in terms of a path it is equal to lambda wavelength. Phase difference of 2 pi corresponds to lambda. Phase difference of pi corresponds to path difference of lambda by 2. Therefore, from these equations we can say that a phase change of pi or a path difference of lambda by 2 occurs on reflection from a surface backed by a denser medium. Here the reflection takes place from first of all, the reflection takes place from first medium to second medium. First one is rarer medium, second one is denser medium. Therefore, the diffraction takes place at the surface backed by a denser medium. From these equations, we can observe there is a phase change of pi or path difference of lambda by 2 occurs when the reflection takes place at a surface backed by a denser medium. This is known as 180 degrees means reverse. 180 degrees change means reverse direction. Therefore, this was observed by Stokes, and this principle is known as Stokes' principle of reversibility. This topic is indicated as phase change on reflection when it takes place at a surface backed by a denser medium. This is about Stokes' principle of reversibility. Thank you.